intro.
Hi guys, welcome back to third part of the FFB build series. In the previous part 1 video, I have shown the simple and easiest way of making the analog racing pedals. And also in the second part, we have built a very powerful force feedback steering wheel. In both of them, we have only concentrated on the hardware part. If you have not checked out those videos, you can get both the links in the description box. Coming to today's part 3 video, I'll be showing the connections for both of them and also the software configuration. And at the end of this video, we'll show the basic working of them. If you guys start looking for the sources for FFB steering build, there are a lot of options and it will be a bit confusing for a beginner. So I'll try to make it clear in a simple way. For building this project, majorly there are two microcontrollers used. One is STM32 and the other one is Arduino Leonardo board. People who have very high budget and more into heavy gaming, they usually opt for this STM32 based build. This is a 32-bit powerful controller and even the cost is more. For my build, I'll be not using this board, so we'll be not going much deep into this. Coming to the other one, which is a budget build, you can go with the 8-bit Arduino Leonardo controller, which is a decent one and more than sufficient for all types of games. Considering this Arduino Leonardo as a controller, we'll start doing the connections. So this is the circuit for the steering and the pedals, and the link will be provided in the description box. First I'll start with the pedals part. I have used three 10 kilo ohm potentiometers. From all these potentiometers, this positive terminal is shorted together and it's connected to Arduino 5V pin. Similarly, all three negative terminals or the ground are shorted together and it's going to the ground pin. And the center pin or the signal pin of the accelerator goes to Arduino A0 analog pin. Signal pin from the brake goes to A1. The signal pin from the clutch goes to A2. So that's it, it's very simple. In the similar way, we'll do the connections on our actual hardware. I'll be soldering the wires for all these potentiometers. Also, I'll be making my whole setup with a plug and play system. So I'll be using this DB9 connectors. And this is how it looks after soldering. I have made this long connecting cable. So one side goes here and other side will go to the Arduino board. Again, coming back to the circuit diagram. So this complete right side circuit is for the steering wheel. Here we have the encoder which detects the steering rotation, and this motor driver and the motor combination is for providing the force and feedback. So in the two-phase encoder, you will be having 4 terminals. So the 5V is connected to the same 5V on the Arduino. Ground also is connected to the common ground. The A phase is connected to Arduino digital pin 0, and the B phase is connected to digital pin 1. So in the software, both of these pins are checked for active low. So in the circuit, we have to pull up both the pins to 5 volt. Means you have to connect a 4.7 kilo ohm resistor from this A and B phase pins to the 5 volt pin individually. In coming to the motor driver, here M plus and M minus is connected to the motor terminals. So in my case, it's a 24 volt e-bike motor. Similarly, this B plus and B minus will be a power supply which is required for your motor. And coming to the control pins, this motor driver also VCC and ground. Again, this 5 volt and ground are connected in common and goes to Arduino 5 volt and ground pins. Right and left enable pins are shorted together and connected to digital pin 8. LPWM goes to digital pin 9. The last right PWM goes to digital pin 10. So all these pin names you can find it here just at the top. So again we'll move on to the hardware and do the connections as I have explained. After doing all the connections as per the circuit diagram, I am adding this DB15 connector, and here also the one side of the cable is connected and other side goes to Arduino board. And finally this will be the main controller box with a connector for steering wheel and also for pedals. And our Arduino board will be placed here. Moving on to the software, for this Arduino Leonardo based build, there are mainly two open source softwares or the firmwares available. One is the RFR wheel config and the second one is the EMC utility. Initially I started with this RFR wheel config. So this is how the interface looks. It has lot of features with game and desktop effects. But while using it, I was getting a lot of errors and it was giving calibration error. And even after trying for many days, I couldn't resolve the issue. So I moved on to the EMC utility. So here again, you get utility Lite and utility Pro. The Lite is a very basic and a free version, whereas the utility Pro is a paid one and you can get lot of effects and controls there. Right now we will be using the Lite or the free version for our build. Maybe in future I'll also try to upgrade to the Pro version. If you open this EMC development Facebook page, you'll get lot of information on different kind of wheels, updated versions of softwares along with enhancements. So you can explore this page for more info. Also, if you are looking for the paid version or the pro version of EMC utility, then you can contact this team and get the required files. Since we will be using the free or the light version for our build, that we can easily download from this page itself. So if you come a little bit down, you will find the link for the light version. So along with this firmware files, we also need some other softwares. In order to make it easier for you guys, I have provided a separate download link with all the required files in the same folder. You can get the link in the description box. Once you download this zip file, just extract it and inside this folder you'll able to see 7 items. So I'll just give the brief on all these things. The first one is the firmware or the software hex file which will be used for our steering build. Second, we have one more hex or the software file which is required to convert back your Arduino into normal. The third one is the EMC utility light installer which will be required to do the configuration or the settings. The fourth one is the wheel check software which will be only used to check the basic working of your steering wheel. Fifth, we have the circuit reference. So this EMC schematics might be difficult for the beginners to understand. In that case, you can also refer to our circuit diagram with actual components. Sixth, we have Xloader software which will be used to flash or upload the hex files to your Arduino board. And at last we have a document file in which they have mentioned the features which is supported and not supported in this light version. Coming to the actual steps, first connect your board to the computer. From the downloaded folder, open Xloader and run this application. So you get this interface. Click on this browse and from the firmware folder, select the EMC light hex file. For the device, select Leonardo 32U4. So initially there is no COM port visible. So we have to take our Arduino into flashing mode. You have to just connect the reset and the ground pin for a second and remove. Then quickly select the visible COM port and click on upload. So you get the status here as uploaded. Next, from this utility light folder, install this application. So this is how the interface looks for the light version. Here, click on this settings icon. We have to add this CPR value based on our encoder PPR value. It's mentioned PPR into 4. Since we are using 600 PPR encoder, so the CPR value will be 2400. Next, we have to select the H-bridge type. Since we are using the BTS 7960 motor driver, we have to select this 2 PWM plus 1 direction. Now we'll start calibrating the pedals. Go to this pedals tab. I'll start with the accelerator. Keep the pedal to its minimum position and click on min. Next, take the pedal to the maximum position you need and click on max. So once it's done, this is how it works. Similarly, I'm repeating the steps for the brake. The clutch and handbrake are optional, so if you want, you can just enable them and calibrate in the similar way. Moving on to the steering tab, here we don't have any options for effects or the controls. Just you have to set your required steering degree. This you can change based on the games you play. Also, there is a force tab where you can increase or decrease the force levels. Finally, I'm connecting the power supply for the motor driver. Now, using the wheel check software, we'll see how the basic force feedback works on our steering wheel. I am also new to this and need to explore more. So as of now, I'll just show some basic tests provided here. Already the EMC is detected, and this is where you get different test options. After completing all these steps, your steering wheel will be ready for the gameplay. In this video, I'll just show a short demo on how this wheel works inside the games. In the coming days, I'll also try to upload more gameplay videos. Since we are using the light version, we cannot set any game or desktop effects using the software. All the force feedback depends upon the data coming from the game. So based on your requirement, you have to adjust the force feedback options inside the game. And one more last thing to be noted, if you want to convert back your Arduino into normal, then you have to flash this return to stock Arduino hex file. For flashing, you can follow the same steps as we did before using the X loader. That's all for this video, guys. But this is not the end. We'll be doing lot more upgrades on this. So stay tuned for all further videos, and if you have not yet subscribed, do subscribe and also follow us on Instagram. If you have any doubts, let me know in the comment section below. Thank you for watching this video, and I'll be back in next interesting one.